In this equation, they say that px is a cubic polynomial, which means that the degree is up to x power 3. After that, the second information, when px is divided by x minus 1, then the remainder is negative 5. The intermediate implication is the remainder. Remainder is p put a suitable x, which is 1, to make the divisor become 0, is negative 5. This is one of the direct implication. Some of you try to build up px by using this divisor and remainder. And then they say that px is equal to qx, the quotient, times x minus 1, and then plus the remainder, which is negative 5. I want to emphasize this is correct. It is correct assumption to rebuild px. And then if you are trying to use a more specific coefficient to express qx, it's because it's cubic polynomial. So if you divide by x power 1, then x power 2 should be left. So therefore, if you need to let the quotient, then you need to let ax squared plus bx plus c. Even though this is correct, but it seems like it's not easy to use. It's because this is a quadratic expression, and 3 different coefficients unknowns are involved. So this is not easy to use. We just keep it in our mind. If there is no better solution, then we will try to let px in this way. Similar reason, when px is divided by x plus 2, then the remainder will become p put a suitable x, which is negative 2. And then the result is 91. We have 2 equations here. And the third one, questions say that px is divisible by 2x squared plus 8x minus 5, which means the corresponding remainder is 0. So this is more convenient for us to build up px, the original function. By using this one, we can say that px is equal to something times 2x squared plus 8x minus 5. So in part A, we let px is equal to something times 2x squared plus 8x minus 5. We apply the same logic here. It's because it's a cubic polynomial, x power 3. We divide by x power 2, so something x power 3 divided by 2x power 2. That will become something x power 1. So we can let the quotient here, it should be something x plus something. We let it be ax plus b. And with the help of these 2 equations, then we can build 2 equations with a and b, then we can solve it. To use the first sentence, since we know that p1 should equal to negative 5, we apply the function that we build up, and then replace every x by 1. Therefore, we have a times 1 plus b. The second factor, 2 times 1 squared plus a times 1 minus 5 is equal to negative 5. Of course, we are going to simplify it. The first bracket, we have a plus b. The second bracket, 2 plus 8 minus 5. The second bracket, all are numbers, so we can add them together, which gives you 5. And then I don't want 5 next to it, so I divide both sides by 5. It's make the left hand side simpler, become a plus b only, is equal to negative 1. From one sentence here, we simplify it, and then it's become a plus b equal to negative 1. That means the coefficient of x and the constant of the quotient add together equal to negative 1. We are going to do similar thing by another given information. p negative 2 is equal to 91. So once again, replace every x by negative 2. A times negative 2 plus b is the first factor. The second factor, 2 times bracket square plus 8 bracket minus 5. Replace x by negative 2. Negative 2a plus b. And the second bracket handle very carefully because negative is involved. And then we get positive 8, negative 16, minus 5 equal to 91. all numbers, we can add them together and then we get negative 13. I just want how many a and b, so I try to divide both sides by negative 13. Whole left hand side, whole right hand side. Left hand side become very simple, negative 2a plus b is equal to negative 7. After we get this calculation, these two equations, we try to combine the result. A plus b is negative 1 and negative 2a plus b is equal to negative 7. I try to use the first equation minus the second equation so that b minus b will become 0. Left hand side minus left hand side is equal to right hand side minus right hand side. Once again, b minus b becomes 0. That's why I don't write anything about b. 3a is equal to 6a is equal to 2. Since a plus b is equal to negative 1 from the first equation, we get b is equal to negative 3. So therefore, we can draw the final conclusion. The quotient, which means ax plus b, is equal to 2x minus 3. A is 2 while the constant is negative 3. We finish part A. In part B, we are going to investigate all the roots of this equation. They are all real number or not. So we should stay close to the given equations here. We should write down solve. Our starting point is px equal to 0. We are trying to solve this equation. We already know about px is this expression. So we try to rewrite it. Updating the a and b, we get 2x minus 3 times one of the factor. To solve this equation, this is a cubic polynomial, cubic equations. Any equations with power higher than 3, our strategy is to factorize it. We already factorized something times something equal to 0. Then by our logic, zero product rules, we know that either the first factor equal to 0 or the second factor equal to 0 will lead to this result. To solve this linear equation is simple. 2x is equal to 3, which means x is equal to 3 to 2. And then right hand side, it is a quadratic equations. You have two choices. You may really use the quadratic formula to solve x equal to something, something, and then you say that is that real number or not. Or there is a shortcut, is when we considering the roots real number, then we can skip the step and we are just consider our indicator, consider delta. Whether the number are real number or not is reflected by this measure delta, which is what inside the square root of quadratic formula. So it's equal to b squared minus 4ac applied to this situation. B is coefficient of x, which is positive 8. A is coefficient of x squared, which is 2. And finally, c represents a constant, which is negative 5. 64 and then plus 40. We get 104. The key point is this value is a positive value. So the square root of a positive value is larger than 0. Since delta larger than 0, so we have two real roots from the equation. 2x squared plus 8x minus 5 equal to 0. So now the result is one real root here and two another real roots here. Therefore, our conclusion, all roots of px equal to 0 this equation are real. Therefore, we agree the statement.